Finally, some more TIG welding content. Today we're going to fit and weld some socket welds. Before we get into any prep or getting the machine cranked up into some settings, let's talk about a socket weld. It's essentially just a way of fitting pipe. You'll have your butt welds where the two pieces of pipe meet together and maybe have a gap, maybe not. Well, this in this instance is just a fitting that has a big enough hole that the pipe that you're using can slide right into it. Just like this T that I have here. This pipe is able to slide in. It'll eventually hit a point where that socket stops, and that is your socket weld fitting. It comes in different shapes and sizes like T's, 90s, 45s, flanges, all the flanges and fittings that you could think of in a socket weld form, they make them. And this is the isometric symbol that you'll see for those types of fittings. We're not going to get too far into that. We are going to fit a little bit of it, but I want to talk more about the fillet weld throat, because as we weld a socket weld, it is a simple fillet weld. It's a little bit more complicated because it's pipe. I notice a lot of welding schools don't necessarily teach socket welds, because if you can structurally weld, say TIG for example on a 2F, and you can do a 5G weld with TIG all the way out, then a socket weld should not be a problem. However, a lot of welders don't come across it in school, and then they get thrown a bunch of socket welds right off the jump because it is an easy weld to make. But we got to make sure that we fill it properly. Depending on what the code asks for as far as weld size, you need to be paying attention to your fillet weld throat. That is the distance and the depth from your weld face to your weld root. That's your theoretical throat. Then you have your effective throat, and then your actual throat. And this all depends on the type of fillet weld that you throw in here. What we're going to do with our TIG welding process is we're going to throw a good root pass in right here, make sure we get good fusion into it. For some socket welds, you may not need a bunch of filling to get in here. I've dealt with socket welds that are super duper thick and need multiple passes, and some are just single pass welds. But most of the time it's a root and at least a hot pass. And a lot of welders will come in and weld that and then get something like this for a weld. It's really dished out. The distance from the weld face to the root is a lot less, so it doesn't necessarily have the strength that the QC might be looking for. A lot of times they're looking to see something at least flush right to the edge of that, but without getting undercut on those two pieces. A little reinforcement probably doesn't hurt, but that's what we're going to be shooting for today when we do this socket weld. Now when it comes to putting together socket welds, right, you have your sockets and your pieces of pipe. You got to think about that when you're fitting them together. Not only that, but we're going to also have to do a little bit of a gap when we go to put it into the socket because of thermal expansion. We'll get into all that. All we need to know is that all of our sockets should be square. Same thing that has to be with our pieces of pipe. They need to be cut to the right lengths. We got to remember that we're going to be adding maybe a 1/4 inch if there's a piece on each end, the 1/8 inch per one. We also need to clean up a little bit higher up on our pipe pieces, because not like a bevel or the edge of a groove weld where we're going to weld right in those edges. We're going to be welding up a little higher on that piece of pipe. I got some of these Walter extra cut wheels. They're like those pad sanding discs that you can slap on real quick, and they had a couple different grits. I didn't need a lot of material removal for my fitting because everything's square. I don't want to unsquare it, so I went ahead and used the 80 grit for that. Now that's still kind of aggressive, and it definitely removed metal, so I kept it on there to get some of the mill scale and rust off. It honestly did find it is actually really nice and smooth, but I wanted to be a little faster and try out these other grits, so I tried the 60. And the 60 definitely had the nicest prep, quick, nice and easy for these little pups that I was doing. I wanted to go ahead and try the 36 plus. I tried it for just a second and realized that I was hogging some metal away, and that thing's more set for kind of putting some bevels on pieces of pipe. It definitely can make that happen in a hurry. The point being, we got to get everything nice and cleaned so that we can get to the machine, get it set up, and get everything tacked together and fit. Now as far as machine settings for a socket weld go, it is very simple, guys. We're not looking at an open root. You might be a little bit cooler on the root pass compared to the hot and the fills. You might adjust things, but honestly you can really set everything at one setting and it'd be pretty good. Today we're going to be running the Lincoln Sprinter 180 SI, the little welder that could. It is a 200 amp machine, so we can get it all the way up there. We have our high frequency or our lift start. I'm probably not going to use a foot pedal today, just for the fact of more of a field application, just like our TIG rig here, the 2-piece TIG rig, being able to operate a much higher amperage than say your single piece TIG rigs. One thing I stumbled on Heavy Hitter's website was the fact that they have jumpers now for pretty much any machine you got. So like this one's your through dense connector that's a little bit bigger than this one. They got a couple different variations and stuff, and I think if you just get a hold of them, they'll probably find you a solution for whatever machine you're trying to hook up to. We've got our argon on. All you got to do is plug in your jumper. I gotta tighten up my fitting. I don't think I did that yet. We'll crank the gas on. I think we're gonna probably start the root pass off. Man, I don't chill out anything less than 150. I think 150 is gonna be perfect. All right, guys, so check it out. When it comes to fitting a socket weld, these are some pretty easy fits to make. But you first gotta get a reference line, something that's absolutely zero, square and level, all that good stuff. So I got my positioner here. It's locked in place where it's not gonna roll around. I've got the part level this way. I've got the part level that way. We should be good to at least tack the one on the top. We gotta try to figure out how we can pull this piece of pipe out 1/8 of an inch. It's not too difficult. All we gotta do is make a little mark. Make a little mark on that piece of pipe right there. Anywhere, doesn't matter where. You have an 1/8 inch piece of filler metal as your filler metal. You can lean that back and you'll see that that line gets to be about 1/8 of an inch. That's me holding that coupon. That's pretty much giving it that 1/8 inch gap that I'm looking for. So I should be able to tack that side. So we got that side tacked. We got that 1/8 inch gap. If there was some sort of roll or whatever we had to be paying attention to, we would make sure we had that too. You still got to fit this side right here. So what we would do, you could sit here and get a square and try to put this square on the fitting, and I could see that I've got to scooch that fitting up just a little bit that way.
Boo! You stink!
And if you move that, then you're messed up. You gotta put it, you gotta. The nice thing about a socket weld and one that isn't really even in place yet, you just gotta make sure everything's square. So I'm just gonna go ahead and move forward with this process here the difficult way. I feel like I'm making this difficult. The biggest thing that you take away from fitting a socket weld is that 1/8 inch gap. And if they're x-raying that, they're not only looking for that gap, but the depth of penetration into your root. Yeah, that's right, they'll x-ray socket welds. You can also do this where we try to get this square. If you had a longer section, you probably could get a tape measure, do one of these. It's 1 1/8, 1 1/16. So it needs to go, you know, trusty hammer, 1 1/8, 1 1/8, good. If it's usually a little bit out, like a 1/16 or just under a 1/16, you could tack one side and it definitely will usually pull. Definitely 60% of the time, works every time. And then that fourth tack is pretty much a sealed the deal kind of thing. After that third tack, it's not really moving anywhere, so it's fine, but that was definitely the hard way. Now I'll show you how I would do it the easy way. All right, so now we're back to level again. Everything's rolled right. All we're gonna do is put that piece in. You're gonna push it in square with itself. We're gonna make that line, but this time we're gonna make that line all the way around. And then it's easier to fit, in my opinion, on the side here. Because you can see as that pipe will drop, you'll get that spacing. Now remember, we're only looking for 1/8 of an inch. We're just going to use that wire as our spacing tool and eyeball it. If you're a welder and you can't eyeball 1/8 yet, come on. Next thing you're gonna do is just look at your line. You can look at your line, all you gotta see is that that line needs to be bumped up to be even. I don't even care if anything's square anymore, at least right now. Get our trusty hammer, bump that up till that line is even from top to bottom. You got that nice even 1/8 little gap, and we go ahead and attack the bottom of this guy. Now I 100% recommend to double check yourself. Right, put a square on it, make sure it's square. The other thing is you can look at the line on both sides. If that distance is the same, I tell you what, you could just about get away with it. And all that trick is just mark a line all the way around and get your 1/8 inch gap. Now remember to still check your level, check your square. Obviously for much longer sections of pipe, if you're off a little bit, you're off a lot of it. So double check that stuff. But all you got to do with a socket weld is get that 1/8 inch and get it square and leveled everywhere. All right, now that we got everything fit, we can start putting our root pass in. I got to admit the tacks felt pretty cold, so I turned up the machine to about 176, 175, 180, somewhere in there. You can hold a lot of heat when it comes to welding socket welds, at least this thick. This is a hunk of metal, right? I think that's some Schedule 80. It's gonna hold some heat. 180 is nothing to sneeze at. When it comes to this root, we gotta get fusion into it. I've seen welders really take their time with this piece, making sure that they get it in there. It's not like it's gotta go all the way down to the bottom here, but we do have to focus our art right on that line, and we can't put a big old heavy bead in. We gotta just put a little bit of metal let it soak in. I'm going to keep everything pretty much welding at 180 amps. Maybe turn things down for the cap, but for the root pass, I'm going to take away that 1/8 inch wire, grab some 332 wire, and I'm just going to dip things in. Scoot a little bit forward and dip things in. Scoot a little forward, dip things in. Not only that, but we fit this thing to be square. So to keep it square, we're going to weld this quarter, then we're going to jump over to this other side, weld this quarter, jump back to this side, weld that quarter, and jump back over here and weld this quarter. Every time we come to attack, we're going to make sure that our puddle flattens that out and lets it sink into that joint so that we get a nice bit of fusion for our root pass. We're not trying to get a big heavy weld yet. We want to try to get that root in. This will never change. Quartering it out, try to get that root in. After that, you might be able to 1-pass it. You might have to 2-pass it to get the weld size you want, but the root won't change. Let's do it. All right, here we go, gang. I'm going to start up just behind our first tack so that I can get it hot and make sure it starts to sink in. And I still haven't added any wire yet, still haven't added any wire. Now I'm just going to dip, wiggle, dip, wiggle. Essentially putting like a little tack and letting it sink. And really the filler metal is only there not to that I need the metal there, but for the fact that this has good arc stabilizers and good additives for the metal to help make a good, clean, healthy weld pool. Now we got to weld this other side. And remember, if we started this way and we started welding that direction, we should maintain that direction all the way around. If I started here, finished here, and I started on this tack and finished on that side, we could pull that coupon. So being that this is a little bit trickier on the back side, I'm just going to freehand it. All right, here we go. I actually do like freehanding my root passes because you can get a really slick looking root by taking that pause and step, depositing metal, get a really slick looking root in there. Whew, didn't make it all the way across. But we don't want to just keep going. We're putting heat all the way around to this point where we started. We still haven't even got to this side. So we always want to try to evenly distribute all that heat. You can even just leave a little bit of filler metal in. There really isn't like one good way of doing this. The idea is to just get good fusion into your root pass as well as getting that 1/8 inch gap on your fit. And then we got to get the proper weld size for what they're asking for. The less starts and stops you have on it will make it look a little nicer. Well, it's been some time. Now just taking a look at this here socket weld, it should kind of look the same. You should have your ripples all going the same direction unless you were purposely trying to pull it some other way. And you should have your 2 stops should be opposite of each other, at least the 2 that are showing. You should have stopped opposite of yourself every single time. That way to keep everything nice and square. When you're welding big long headers and stuff, those stops should always alternate as you go down. It honestly does help keep the whole thing straight and keep things from bananaing, bowing up, because if you weld everything the same, then sometimes everything wants to pull a little bit. Like if I welded both of these pieces bottom to top the whole way, then I might get a bit of a banana. But if I weld this one bottom to top and then I roll this and it can weld this one bottom to top but upside down, then it keeps everything in equilibriums. And that's what you're trying to think of when you're building anything as far as off of a wheel or on some jack stands, doing some prefab. When it's in the rack, weld it however it gets. But as far as the weld size with the root, it is not at all filled in whatsoever. So now we got to start getting the proper weld size and just filling it up. Now once the root's in, you don't have to really quarter much of anything. Everything's pretty solid, right? You put a weld in it already. We're also going to switch to 1/8 size wire. Still got the same amperage, 180. Now we're going to try to weld about half at a time. If I can get all the way around it, that would be what I would be trying to do, is just keep it going, keep it going. But being that, this is kind of in my way, we'll just do half at a time, but we're going to keep that weld going all the way around. And right now I'm not going to focus on adding a lot of heat. I'm just going to do a simple lay wire tactic. I'm even going to let my weld be a little bit concave. I'm not trying to carry a lot of filler metal. At this point, you can have enough amperage and feed your filler metal and get this done in one pass. But we're going to take it nice and easy. And as you notice, my body keeps moving around this because unlike plate, this is pipe. and you have to keep moving around it. If you've seen any of my tutorials on walking the cup, all I'm doing is applying pressure into this pipe and staying in front of my torch. Now because I can, I'm going to go ahead and loosen the chuck up and flip this pup around because I want to be able to walk it all the way around and that chuck is in my way. So to keep everything nice and consistent, that's what we're going to do. We'll lock this wheel back and we'll keep welding around. And we'll check out that effective throat, the throat that we got on this fillet weld after I get this on. I always like to run a little bit of a wire wheel on my stops, especially if I'm using a scratch start setup or a brush or anything, especially on the root pass. Clean it up a little bit, it makes the weld look way better. And you'll just kind of see where your steps left off, start behind where you stopped, get that thing nice and hot again, 180 amps, here we go. But as you guys can tell, we're just lay wiring this wire right now. I'm not trying to feed into it. If anything, I'll try to stay a little bit towards the top side of the weld. And as soon as I see that I've got close to the edge of that socket weld, I'm out, back to the top. I don't want to burn up that edge and let that weld roll out just yet, or really at all. But we still probably have another pass to make before that socket is completed. Second pass is on. Nothing special, guys. This really is an easy weld to make. It's just a fillet weld. You've got to get used to moving around a piece of pipe and really watching your edge control, trying not to get undercut on that piece and trying not to roll too far out of it. That's why I'm carrying just almost no metal, just lay wiring it, keeping it real chill. You can even turn it down a little bit colder if you want to move a little bit slower. But you'll see those nicer colors in there, and that's from having a proper amperage and a nice travel speed. One other thing to consider is that our fillet weld we're still at a concave fillet. We need to be either flush or a little bit convex. So we're probably going to have to add another pass. A good welder may be able to do that root pass and then go ahead and do that one pass and get done with that socket weld, because essentially these things, they need to get done. They usually don't come in 1 or 2 or 3s. They usually come in 50s, 60s, 70s, 100s, 200, 1,000. Like, I welded socket welds for freaking weeks till I was sick in the face of it. That being said, you get good at it, get consistent. One last thing that I'll say before I move on to the next layer is I have a stop right here looking at me in the face. I want my next stop to be on this side. That way, even though I'm still going around, I don't want to finish all in the same spot. I'll start on this side and come around and finish right here so that my stop is opposite of the previous pass I did before. Again, when you're working on bigger pieces and sections, this will keep everything straighter. And just like before, I'm going to go ahead and hit it with the jimmy. Still got 1/8 inch wire, still got 180 on the amps. I'm going to have that wire more towards the top of the bevel for sure. And I'm going to make sure that when I see that bottom hit that one edge, that I'm coming right up. And I'm going to try to get you guys the right arc shot. You'll see 2 lines on the socket typically. There's one that's like the very outside diameter of the socket itself, and then there's that one that's got like that little chamfer piece where they put a radius on that socket. That's that edge that I'm looking for, and the edge that I'm trying to make sure I hit and go no further than. But once I see my other stop from my previous pass, I could probably come off of it. Unless I'm able to walk all the way around, then I'd probably just keep going all the way around, because it definitely could. But that's the size that we're probably looking for. I'm going to go ahead and flip this old dog around, give it a jimmy. Keep welding. Start behind where you stopped, so you can get your steps back, get your puddle back before you introduce that filler again. Coming up high on that piece of pipe and just hitting that first line on that socket, hitting that first line on the edge, bottom edge of that weld. I don't want to see it come out, then it comes looking like it's got a weird roll. There's sometimes if I want to put a 2-bead pass as the cap, I might go a little bit past that line, but for this we're not. Whew, really snapped off terribly there, got some arc marks and some gnarly ones. Now we're starting to see the fillet weld size that we need after 3 passes. Well, it doesn't matter how many passes it takes to get there, it just needs to get there at least flush. And even still, there might be some discrepancies with the top side of that weld. You know, Mike could just put a little bit more on it. That might be the QC's problem. So just be sure that you talk to your QC and let them and ask them what they're looking for. One thing you should not even allow them to see is the little button there not being cleaned up. In my experience, they want that sucker already cleaned cleaned up with a grinder. It's a good time to get one of those Walter Extra cuts out and go ahead and clean that up. And any type of arc strike you see, go ahead and touch that up. Hit it with a file, a little bit of wire wheel. Get that stuff cleaned up before the inspector comes by, because they're just going to tell you to fix it anyway. And if they come over 100 times and tell you to have to do the same thing over and over and over again, you're not going to make any friends that way. I'm going to try to weld these other two out. I'm going to weld them in position. Still going to roll them. I'm not going to weld them in position. But I'm going to get these other two knocked out because I just want a nice little coupon to finish off the day with.
We're welding everything bottom to top. Helps with some fusion too. 332 all the way up, just wiggling it in. Trying not to carry very much wire at all. Get to the tack, take the wire out, knock down the tack. I didn't quarter this thing out, but you know, do as I say, not as I do kind of thing, you know?
Now we're going to keep rolling it. And the reason why I didn't quarter it out is because I'm welding it out like this. I'm rolling it a lot. I'm welding it fast. I'm alternating my starts and stops, and I'm actually going to try to carry a single bead on this one. I don't like this one as much. Starting to cut into it a little bit more. Maybe I need to chill out my amperage, just for the fact that we're welding this 5F-ish position. Probably going to go ahead and run another pass over it just to clean it up. But I'm going to continue adding a little bit more wire than usual on this second pass compared to that previous one we did together. Not winning me any awards on pretty, but it's getting the job done in a single pass. Let's talk about it. Now, taking a look at this weld, we got it done a little bit quicker this one. We got it done actually significantly quicker because I just welded and wasn't really talking it through. But we got some problems with it. The weld size isn't the same. Typically, whenever I'm on the bottom and on the side, it's a little heavier than when I come across the top. And it shows a little bit. We have a little bit less weld on one side and a little bit heavier in some spots. A little bit of underfill, undercut kind of stuff. And the color is a little bit less aesthetically pleasing. That's not necessarily a huge issue with carbon steel, but it's because I'm trying to run a little bit more wire. It's making me weld a little bit slower, and that's why we're seeing all these things. Are they going to hurt us? Not necessarily, but it's something that I want to try to mitigate. What I'm going to do now is just clean this joint up, and I'm going to run another piece of wire, and where I see that it's heavy, I'm not going to add a whole lot of wire, but where I see that it's low, I'm going to need to put some bead in it. Now remember, some spots are already there, some need a little bit to fill. We're going to do our best and knock that out. I went ahead and dropped my amperage down a little bit so I could be a little bit more meticulous.
We're at 170 now. If I notice the right or left side needs wire, I'll end up moving that wire over there to either the right or the left side, or the top or bottom, being that we're in this 5F. Trying to make sure that I'm shaping my weld right. It's almost counterproductive, at least for me, to have to do this second pass if I try to get in a hurry, because we're going to end up taking us the same amount of time.
Me being out of practice. Again, that weld size is just a funny looking shape compared to the top and the sides. It's something that I need to work on right now, and something you need to be aware of. Well, that about wraps up today's weld, everybody. I hope you got some value out of this and what a socket weld is and what you're looking for as you go about doing this. It doesn't matter whether you're using the gas tungsten arc welding process, or maybe you're MIGing it, maybe you're sticking it. Hell, you could even flux core the things. You just got to know what weld size you're looking for and what it's going to take in order to get it there. Thanks again for watching. Please check out our links down below in our description, from Outlaw Leather to Walter to Ariat. We'll see you guys on the next weld.